Hello, I'm Naina Harviti and I'll be presenting GMAT in aerospace. The GMAT, or the General Mission Analysis Tool, is the world's only enterprise multi-mission open source software system for space mission design, optimization, and navigation. The system supports missions in flight regions ranging from low Earth orbit to lunar libration point and deep space missions. GMAT can be downloaded easily from the NASA's official website. The download button will redirect to the source code page and the software will be downloaded in zip. The .exe file is located in the bin folder after extraction, and the software will run upon simply just clicking on the .exe file. You can see that this is the welcoming page of GMAT. To represent how this interesting software works, we have chosen the Hohmann transfer. Hohmann transfer is fuel-efficient orbital maneuver used to transfer a spacecraft between two coplanar circular objects. It was named after German scientist Walter Hohmann from his book, which was published in 1925, Die Erreichbarkeit der Himmelskörper, or the attainability of celestial bodies. Now, to represent the implementation of the GMAT, we will go to our software. And in here, you can see that under the Resources tab, two burns are necessary. As this transfer is occurring between the central body, which is Earth, and one of the satellite. So the two burns here, you can see the transfer orbit insertion, final orbit insertion, and we will see our output in here, default orbit view and default ground track plot. Now we have to go to our mission sequence where we needed three kinds of orbits, and we color you can see that these orbits are parking orbit, transfer orbit, and final orbit. These orbits are color coded. Parking orbit is in red and the transfer orbit is in blue. The final orbit is in yellow. We also had to set parameters for delta V, and the two delta V's are TOI, transfer orbit insertion, and FOI, which is final orbit insertion. So after the setup of parameters, we can run and animate our simulation for default orbit view and the default ground track plot view. Now we will animate. This is our default orbit view. In the animation, you can see that this is using Hohmann transfer. The red one is the parking orbit, and the blue one is the transfer orbit, and the yellow one is the final orbit. And after that, we can also see the default ground track plot, which is this one. After the animation, you can see how it looks on Earth or from Earth or the bird eyes view. So our spacecraft was named actually Earth Hohmann. So this is GMAT. Now let's get back to the our presentation slide. In conclusion, we can say that OpenVSP, SketchUp, and GMAT, these three software tools, each offer unique ways to support aerospace projects. From aircraft design to 3D modeling and space mission simulation, they cover diverse stages of development. So they actually show the power of computer graphics in advancing aerospace innovation together. Thank you.